Hello. Can you hear me already? Hello and welcome. My name is Thomas Binder. Welcome to EXL 412, Lync Deep Dive Edge Media Connectivity with ICE. Today, we're going to talk about Edge Server. Why do we need an AV Edge Server? What's so special about this role? How does it help us in our Lync environment to do additional scenarios, remote scenarios, that we wouldn't be able to do without an Edge Server? How will a Lync client, when it tries to call another Lync client or a PSTN phone number, find the most optimal media path so that we don't need to go to some data center, to some proxy server if we don't need to, but can send our media traffic directly? And finally, we will talk also about how do I read client logs. So all of what the server is doing, what the clients are doing, how can I, as a user or an administrator, someone who needs to troubleshoot that, how can I understand what is happening there, and how can I see how it happens? So why are we going to talk about that? Well, first of all, I think it's pretty interesting. I hope you find it interesting there. But it's really great to see what Lync does to find this optimal media path. It is really important to see what's happening here, to understand call flows, to understand why a specific voice packet is going to a user on a specific media path. And it will help you to troubleshoot. If you had ever problems with your AV Edge server, not being able to call remote users, not being able to call users between different sites, this session will give you the foundation to understand what the problem is behind it. In terms of agenda, first we will start to talk about the general problems for media connectivity. So why do we have an AV Edge server in the first place? Then we will talk about the protocols that we use to solve these problems. We will talk about how a media session is established, and we'll look into a lot of log files to see it happening. Finally, we will talk about call flows, and in the end have some time for Q&A. To introduce myself, my name is Thomas Binder. I'm based in Austria in Vienna. I work for Microsoft. I'm with Microsoft for over 5 years now. I started in 2007, working on OCS 2007. Back then it was the Beta 3 timeframe. Worked also on R2 and on Lync. While I used to be a local consultant in Microsoft Consulting Services Austria, last year I moved to a more international role. I'm now part of the Voice Center of Excellence. I'm an UC voice architect there, and the agenda of my group is to drive the largest Lync installation worldwide. So if there's a very large customer, it's very likely that our group gets involved. I'm also a certified Lync master for, I'm a certified Microsoft certified master for OCS 2007 and for Lync 2010. And I'm also teaching at Masters about exactly these topics. So if you ever go to Masters, we will meet again and we will talk about Edge Server. If there are any open questions, I'll try to answer as much as possible in the end. I will also try to make myself available during the rest of TechEd. If there are still open questions, tbinder@microsoft.com. That's my email address. It's also my zip address. Feel free to ping me and follow up on your questions. Just to set the right expectation about this session, it's a level 400 session. That means it's supposed to be very technical. We limit ourselves here to media scenarios, so we'll not talk about signaling, how that exactly works. I expect you to already know all of that, or have at least a basic understanding. So you should know why we use SIP, what SIP is doing. You should know RTP. You should know what Lync server roles we have. And you should know how a Lync topology looks like. If this is the first time you hear about Lync, I've heard there's another session by Mark Rusinovich right now, which is really popular. Might be a better use of your time. We are going here deep into Lync. So this is supposed for people who know Lync. So now is the perfect time to leave. I won't judge. During this session, I will use a number of acronyms that will come up really a lot. So first of all, I will speak about candidates. A candidate is a possible endpoint for a media connection, and it consists always of a port and an IP address. So combination of IP address and port, that's one of our candidates. We will talk about ICE. ICE, the Interactive Connectivity Establishment Protocol. We will talk about TURN, traversal using relay net. It's one of the protocols that actually ICE is using when we try to create a connectivity. The very important word here is relay. So somehow there's a relay involved in turn. And then there's STAN. STAN has actually two meanings. One would be simple traversal of UDP through net. That was the original acronym. During time, it evolved. So STAN is not only used for UDP, so they needed a new meaning for the acronym. So now it's Session Traversal Utilities for Net. And these terms will come up during the session quite a lot. Let's start with the problem, NAT, Network Address Translation. A NAT device is a device that does network address translation. Easiest example would be a home wireless router. So I have at home an internet connection, I have a wireless router. From my public internet provider, I get one IP address. Though, well, this points to my home router, and behind my home router, I have all my different devices connected from home. And they will have private IP addresses, so that's 192 address and so on. And the great thing is that my router does this net translation. So I can send out traffic to the internet. The router will translate it to my public IP address, send it out, and everything that comes back, the router will remember, well, I sent it out, so I need to send it back to the correct user. And that is really great. For one reason, I can have as many IP addresses in my internal network as I want, well, virtually, but definitely enough for my home network. And there is some security that comes with it. If someone from the internet just sends traffic to my net device, to my public IP address, well, the router will not know what to do with it because there was no request coming out before from my internal internet. So this traffic just being sent to my public IP address, it's dropped. Router doesn't know what to do, so there comes security. At the same time, if we talk about media session establishment, if we want to do a voice call, a video call, or anything else, that becomes a problem. Because if someone else knows, well, my public IP address and wants to call me and just starts to send voice packets to this public IP address, well, the router will drop it. I will never get these packets, and we will not be able to have a call if I'm sitting behind a net device. If we look now at companies, it gets even a bit more complicated. Usually, companies have two firewalls. They build this perimeter network, and they have an outer firewall and an inner firewall. From the external network, from the internet, usually it's possible to send traffic to this perimeter network, so I can traverse over the external firewall on configured ports, of course, to specific IP addresses. But it's possible to establish a connection from the internet to the perimeter network. However, from the internet to the internal network, that will always be blocked for security reasons. If I want to go the other way around, if I'm talking about going from the internal network to the internet, it's very similar. Most of the time, internal resources from the internal network will be able, on specific ports to specific IP addresses, to go to the perimeter network, but they will never be able to go directly to the internet. Again, if we want now to establish a media session, if I have an external user who wants to send some traffic directly to an internal user, this is going to be a problem. And we have this problem actually for all services, not only for media traffic, but also for the signaling. So when I want to sign in with my Lync client, I need to send my SIP traffic somewhere. And for SIP, we have a very easy solution. We have our Edge server, which runs the Access Edge server as well. And my client will use an SAV record to discover this Edge server, and I can send all my SIP traffic there. And that's pretty static. It doesn't matter where I'm located. I will always send all the SIP traffic to my Edge server. That's not really a problem because, well, SIP signaling, it's not as time sensitive. If I have there a few milliseconds more, no problem. It would be different if we talk about media. If I want to establish a media call, if I want to send someone voice or video, every millisecond is important to me. So, for example, I might be traveling from Austria to this nice event here, and I'm at my hotel, and I call another user being also in the same hotel. So I really don't want all my audio traffic going back to my server, to my proxy, and then to the other user, if I could possibly have a direct connection. For signaling, I don't care. if I send an instance message, well, I can send it back to Dublin or wherever my data center is, and then it will go to the other server, maybe to the other user. Maybe it takes a few milliseconds more. But it's just instant message and presence. If I have an audio call, well, I want it to be as quick as possible, so I don't want to have this one static server where I always send all my audio traffic. So we want a smarter solution there, not just one static proxy server. So let's talk again about this problem and how it looks now with having our Access Edge server. So on the very left side, you can see my home user being at home behind the net. And on the very right side, you can see the work user. There's an outer firewall and inter firewall. The home user is behind the net. And over the Access Edge server, it's static. It's a static proxy. It's easy to find. We can exchange signaling. So I can tell the other user, well, actually, I would like to call you. I do have on my home client, I have a candidate, a local IP address, and a port. And so I have a candidate on my work server, on my work client. For obvious reasons, they won't be able to communicate to each other. Well, the work user, he will not be able to send from the internal network to the internet. And even if he would be, he wouldn't be able to traverse the net. At the same time, the home user wouldn't be able to traverse the inner firewall of the company. The solution here is stun, turn, and ice. The first thing we are going to do is we introduce a media relay. The media relay, well, it's basically the AV Edge server. And the AV Edge server now has two functions. The first one is the stun that helps me to discover a reflexive address. So we have here the stun server, and now my home user, before we establish the call, will send a packet to the Edge server, and then the Edge server will discover my public IP address and tell me my public IP address. So I'm sending a packet. I'm in my home net. I only know that my private IP address is something 192 whatever. Now I send the packet to the Edge server, and the Edge server tells me, well, actually, if you send me a packet, I can see this IP address. So this might be your public IP address of your stun. Now I discovered a new candidate. Then there's a second functionality. It's the turn. The turn is really a relay working as a proxy. The stun might already help me to establish a connection direct to my client. But in this case, having the work user behind firewalls, even if I know my own public IP address, the other user will never be able to connect to this IP address. So the Edge server also gives me relay addresses, so that in case we cannot establish a more direct path, we will still be able to talk over the Edge server as a proxy. ICE is the overall process that helps me to discover all my candidates, helps me to exchange them, and also helps me to find the best one so that we can have a media connection. All three protocols are based on IETF standards or drafts. Okay, so in a typical Lync environment, where on the very left side you have all the external users, including remote, including federated, anonymous, then I have my perimeter network, reverse proxy, and Edge server. I do have my internal network, director, front-end, back-end, all the server roles. I have internal clients. And I have my telephony environment with my SBAs, SPC gateways connected to the PSTN. Question is now, who uses ICE? What will be an ICE endpoint? Well, the Lync client itself, well, yes, it's an ICE endpoint, so you can see the little ice cube here indicating it uses ICE. Every time I want to do an audio call, video call, desktop sharing, file transfer, I will use ICE to find the most optimal media path. Lync web app, if I join a conference, will it use ICE or not with the Lync web client? So who thinks it uses ICE? Well, the question is, what workloads can I do on the Lync web app? Well, I cannot really do audio, I cannot really do video, but what I can do is desktop sharing. If I'm only the observer of a desktop sharing session, I'm not using ICE. I'm just downloading everything over the reverse proxy. If I'm the active sharer in a desktop sharing session or application sharing session, well, I download this little plugin that I need to do that, and then I will use ICE. So to find the most optimal media path to send my desktop sharing traffic to the internal server. So yes, the web client is an ICE client. Lync phones, of course they are ICE clients because they are doing audio calls. What about Roundtable? Is Roundtable an ICE client? No, it's not. It's just a webcam. It's a very fancy webcam, but it's just a webcam. It will be always connected to a computer where you run the Lync client, and this Lync client will be your ICE client. Going on, front-end server. Yes, front-end server is an ICE client because we run some services there that use ICE. One would be the application sharing MCU, always runs on the front-end server, using ICE to establish the most optimal media path. Others would be response groups, call park service, and so on. AV conferencing server, well, most obviously, AV is doing a lot of AV. So it is an ICE client. Mediation server. Yeah, also, we are doing audio calls to the mediation server. If an external user wants to call a PSTN number, we need to find a media path that enables us to do so. So it is an ICE client. What about SBAs? Is an SBA an ICE client? Yes, an SBA is an ICE client because an SBA runs a mediation server on it. SBC, Session Border Controller. Well, I guess in theory it could be an ICE client. There's just no supported way in Lync today to do a direct Lync call to the SBC and use it as ICE endpoint. So no, that's not. What about gateways? I see a few shaking heads. What is if I'm doing media bypass? Media bypass doesn't do ICE at all. So that's excluding. Even if my gateway is doing media bypass, the gateway will never be an ICE endpoint. Exchange UM? Yes, sure. I can, with an external client, I can just call from Lync to my Exchange UM server. Director? No. Director is doing signaling only. What about the Edge server itself? Well, the Edge server, we just learned, it's a very important piece in my ICE process, but it's doing really just the stun and the turn. So there's a stun and a turn arrow, but it's not an ICE endpoint. So instead of an ICE cube, there's just a soft ICE. Still ICE, but not an endpoint. Okay, so now we know why we want to do ICE. We know what components in our environments are going to use ICE. Now let's look into the detail how the ICE process looks like. And the ICE process really has 5 steps. The first step is I need to be allowed to use my Edge server. So I need to have some credentials so that the Edge server will allow me, whenever I need to do a call, to use it. So the first step happens during login. I need to get Edge credentials and learn where my Edge server is. Then, every single time I'm trying to establish a call, we have the following 4 steps. First is address discovery. I want to call someone. So before I tell the other person, well, I'm going to call you, I need to find out where can I be reached. What are my local IP address candidates? What are my reflexive candidates? What are my relay candidates? Then I exchange these candidates with the person I want to call. Then we will have connectivity checks. So as part of ICE, the clients will try to find out which are the possible media paths that we could use. And finally, we will promote the final candidate. And this is the candidate we're going to use for the call to have a media session established. Let's start with the first one, credentials for the remote client. Situation here is I have an endpoint in the internet, I have my outer firewall, then I have my Edge server. Please note in Lync, the Edge server will always run all the roles. It will run the role of the Access Edge server, the AV Edge server. It's not separate servers. I just draw it that way to understand which process we are talking about. And then I have my Lync front-end server. So what usually happens is the endpoint discovers an SRV record, finds an Edge server to sign in against, and then logins to the Edge server and does a zip register. And there's coming back a 200 OK, what we call in-band provisioning. The in-band provisioning will tell me all kinds of settings for my client. So I will learn what meeting policy I have. I will learn what the normalization rules are, if I want to do a voice call, if I dial a phone number, and so on. Part of it is also the so-called MRAS URI, the Media Relay Authentication Service, that tells me, well, for me as a user, there is an AV Edge server configured, and that's how it is identified within Lync. The next step will be, I will send a SIP service request to my front-end server and tell the server, well, I'm located in the internet or internally, but this is my location. Please go to the AV Edge server and get credentials for me. As we know, the Edge server is not part of my Active Directory. So the Edge server is never able to authenticate me. Even if I go there with my domain username and password, the Edge server wouldn't know what to do with that. When we want to establish a call, we want this to happen as quick as possible. We don't want any delays here. We want really hit the call button and the other endpoint to ring as quick as possible. So the AV Edge server needs a way to authenticate me. And the easiest thing is to do it like that. So I tell the front-end server, get me credentials. The AV Edge server, in its configuration, knows to trust the front-end server. So whatever the front-end server asks the AV Edge server to do, the AV Edge server will do. So in this case, the front-end server will connect to the AV Edge server and will say, well, I need credentials for this specific user. Please create it. Because the AV Edge server trusts the internal server, because they have certificates to identify each other, to verify that this is a trusted connection, the AV Edge server will do that. And the AV Edge server will use the AV authentication certificate on the AV Edge server to create a username and password. We'll send it back to the Lync server on this trusted connection, and then the Lync server will send back a 200 OK to the user, so that the user knows now the name of the server. Well, it's the edge.contoso.com. It will learn the ports that it needs to connect to, and it will get a username and a password. And there's a duration attached to it in minutes, so that's valid for 8 hours. So after 8 hours, my user will go back and ask for new credentials. So now every time I want to do a call, I just go to the AV Edge server directly. I present this username and password. And because the Edge server was the one creating the username and the password, it knows, well, I can trust this user. The user is supposed to allocate candidates, so I'll give these candidates to the user. In a conferencing scenario where I have anonymous users, it's very similar. So here, I have on the left side again an endpoint, and that could be a Lync attendee client. So the user joins the meeting. In that case, we don't really sign in. With the Lync attendee, you can't join as anonymous. And the front-end server knows, well, yeah, this meeting is going on. This user is supposed to be part of it. So again, asks for credentials and sends it back to the user so that the user will be able, even anonymously, to use the AV Edge server and join a conference with audio, video, and desktop sharing. OK, let's take a look at the log. What I, as a user or administrator or troubleshooter, can see here happening in regards to the provisioning of credentials. What we are seeing here is the Snooper tool. Who has used the Snooper tool before? Perfect. So if you haven't, the Snooper tool is part of the Lync resource kit. Just download it, install it, and then you can use the Snooper tool. You find it in tracing folder. You can just copy and paste it to your work machine. That's what I did here. So I have Snooper always with me so that I can look into logs. The log we are looking here is the Lync log. Just enable logging within Lync. And in the user profile, in the tracing folder, you will find this log. And you could read it with a text editor. It's basically just a text file. The Snooper tool just does a lot of great highlighting. So you can see here, I selected one row, and it highlights other rows. That means these messages are connected to each other. Makes it much easier to actually read the logs. So what I did here is I just signed in. I didn't do anything special yet. If you want to do this yourself, if you want to see that happening in your own logs, I would always recommend create a new log, a fresh log. So delete the old log, sign in freshly, because if you are already signed in for a few hours, maybe these things are already dropped from the log and you won't find them. So I just signed in. And the first thing I want to know is I want to see how I get my MRAS credentials. So I'm searching for MRAS now. So there is the search option. I search for MRAS, and if everything is configured correctly and everything is working fine, I should get I should find 3 messages. The first one is the in 200 OK, and that's actually the in-band provisioning. If we look at that, we can see here all kinds of settings that my client learns. For example, I learn I have to show recent contacts, max photo size in kilobytes, and so on, photo usage. So the client really learns from the server what it is allowed to do. We are interested in the MRAS, so I'm going here. It's quite a long list of settings that I get, so I'm going down here. And eventually, there should be something saying MRAS. So my client learns now there is an MRAS URI. So far, I'm not able to use the Edge server. All I learned is that there is an Edge server configured for my user. To configure an Edge server for the user, an AV Edge server, it's done on a pool level. So you go to in Topology Builder to the pool and say, well, for this pool, use this specific AV Edge server. And seeing this result in my log, I know, well, an AV Edge server is configured for that user. Now I'm looking at the next result. And what I can see here, it's the service request my client sends out to the front-end server and say, please get me credentials for this server. This is the zip URI of the server. So this is how the front-end server identifies this AV Edge server. And I give additional information like this is my zip URI, that's the duration, that's my location, and so on. The next result I have here is the response from the server. And that tells me actually, that provides me actually my credentials. So I can see here my username, my password, a duration, and media relay. The location, so I'm in the internet, the host name of the AV Edge server, and the ports I use. If I would sign in internally with an internal client, not from the internet, then I would not learn the external FQDN of the Edge server, but I would learn the internal FQDN of the Edge server. That's the FQDN I need as a user, I need to connect to establish a media session to request candidates. From a troubleshooting perspective, that helps me already a lot to see these 3 results. If I don't see the first one, it means for my user, there is no AV Edge server configured. So I need to go back to Topology Builder, configure an AV Edge server. If I see the first one, I will always see the second one because that's just my client reacting to this message. If I see the third one, I know my front-end server is able to communicate to my AV Edge server on port 5062. That's the port that we use for the MRAS credentials. If I'm seeing an error here, if I not get credentials, but here's an error, it would be a timeout error, I would know there is something wrong between my front-end server and the Edge server. Typically, it could be, well, a firewall. It could be a DNS problem that my server is just not able to resolve the IP, and so on. So that's already very useful. OK, so now my client is able to, well, knows where the Edge server is and is allowed to use the Edge server. We do this once when we sign in or every 8 hours. Now I want to call someone. Before I call someone, I need to know where the person can reach me. And we do this every time when we do a call. Because, well, it could change. I could connect to different networks, additional networks. My AV Edge server could go online or offline. There could be a pool of them. So I might use a different one. So we really need that to do that before every call. This slide is specific for an audio-video session. So it would look a little bit different if we talk about desktop sharing or file transfer. We'll address that in the next slide. The first thing we are going to do is we discover our local candidate. So I have one network card here. I discover a local candidate. For local candidates, we will always only discover a UDP candidate because we expect that if a peer-to-peer connection is possible, that it would be on UDP. And for audio-video, UDP is always preferred, as it will give us better quality than TCP. Then we connect to our media relay, and we will allocate our net, our reflexive. We will discover our reflexive address, and we will allocate a candidate on the media relay. And we do the same for TCP. So now I know, well, these are the options where the other person could call me. If we talk now about desktop sharing and file transfer, it is different because both these workloads require you to use TCP. Desktop sharing uses the remote desktop protocol over the real-time protocol, so RDP over RTP. And file transfer also just TCP. So in that case, we will discover a local TCP candidate, and when we contact the Edge server to allocate candidates there, we will only discover TCP candidates. There are some additional candidates that you might be able to discover. One example is you have multiple network cards. For every network card that you have on your machine, you will discover candidates. Another example would be UPnP. I think Windows XP still supports UPnP. It's a protocol where you can talk to your net device if it supports UPnP, and where the net allows you to, well, allocate a candidate directly on the net. Perfect. So now I know where I can be reached. I want to call someone. Next step is I send the SIP invite to the person I want to call. Please note, this is simplified here. Of course, the SIP traffic would never go peer-to-peer. It would go from my client to my front-end server, to the other person's front-end server, and then to the other client. If one of the clients is external, there would be also an access edge involved. But from a flow perspective, I sent the SIP invite to the other peer, telling the other person, well, I want to call you with that workload. These are the candidates that might be able, well, that we might be used to have a conversation. Now the other endpoint does exactly the same. Before the other endpoint responds, it tries to discover all its candidates. When it has discovered all its candidates, it will send back a SIP message to me, and you will see in the logs a 183 session progress. So far, I have not picked up, no one has picked up, but we are already exchanging all the candidates, and we will already establish a media session. So without the other user picking up, we will do all the ICE negotiation to establish a media session so that at the time the person picks up and says hello, that we can get sure that we have this early media included in our conversation. If we wouldn't do that, if we would wait until the other person picks up and establish the media session then, the person would pick up and would say hello, but the other person would never hear it, and it would be a really awkward situation because, well, both are waiting for the other person to say something and are not aware that they are already connected. Okay, so there is this session progress. And then finally, now someone picks up on the other side, the 200 OK. That means this is the endpoint that we are going to use for this call. And here are my candidates again. Now let's have the call. And we are going to look now again at the log to see this happening. I'm now searching for candidate. Because this will help me to find, well, the candidates in my log. And the first message I'm interested in is here this out invite, where I'm trying to call my colleague Amit. So I click on this out invite. And here on the right side, I can see now the so-called SDP, the Session Description Protocol. Some people, as a mnemonic, refer to it as the self-description protocol, because what it really is me telling the other person what I can do. So it tells the other person, this is an audio call. So here you can see it's an SDP. This is an audio call. I can do all of these fancy codecs, so the numbers refer to codecs. So now the other person knows, okay, we can maybe negotiate this or that codec. And, very important, it has all the candidates in it. If you look at this message, you will realize that there are actually two sets of candidates. So I'm scrolling down now, and there's another set of candidates. Looking up again, I can see that the first set of candidates has this content description of MS Proxy 2007 fallback. The reason is, between OCS 2007 and OCS 2007 R2, the ICE draft was updated, and we updated our implementation. So before that, it was ICE v6, and now we are using version 19, which is a little bit different. However, we need to get sure that if a Lync client or an OCS 2007 R2 client talks to an R1 client, that we can still have this conversation. So I cannot just send out the new candidates, the new format. I need to also include the old format. So whenever we send out an invite, you will see the old format and the new format. So I will scroll down to the new format because the new format is easier to read and easier to discuss what we want to show. So I have here this long list of candidates. And you will realize that there's this first number. For the first two, it says 1. For the second two, it says 2, and so on. Reason for it, candidates always come in pairs. 1 is used for the RTP traffic, the real-time protocol, and 1 is used for RTCP traffic, the real-time control protocol. The next number indicates if this is candidate 1 or 2 within this pair, and then I can see it's UDP or TCP. Going on, I can see here a quite long number, up to 10 digits. That's the priority of the candidate. The higher the priority, the better. This is how the client figures out, well, if there are multiple possible ways to communicate to each other, which one is the best. Then I can see the IP address, and that's my local IP address of my machine when I am at home. So this is the local IP address coming together with a port. And here it says also the type. The type is host. So just by looking at type host, I know that must be a local IP address. Now going on to the next one. Seeing here at the first side, it says relay address. So this is a proxy address hosted on the server, on my AV Edge server. And I can see here the server reflexive address. So this is the address of my net device, the reflexive one. If I look here at this candidate, again, it's UDP as a priority. And then I can see here this IP address. This is actually the IP address of my net device, my reflexive IP address. And I can see here again my local IP address, because the local IP address was used to identify that. So if I have multiple network cards in my computer, I will see where the packet was sent to the edge server to discover this reflexive address. And I have here as well a port number for this candidate. Relay address, very similar. So I have here the IP address of my AV Edge server, and this now is the address that I used to discover that. One other thing that you can see here, is for UDP, all candidates will be always UDP. That means we can send and receive on UDP. For TCP, it's different. For TCP, we have TCP passive and TCP active. TCP active means this is a candidate that I expect to send traffic to me. TCP passive means this is a candidate that I expect to be able to accept traffic that I send to it. So if you look here at the pair number 2 and the pair number 4, and you look at the IP addresses and the ports, you will see that's actually representing the same candidate. But it is a candidate that will be able to send and receive traffic. So we will try to send traffic there when we try to establish a media connection. And this is the relay address. On the other hand, we have also this TCP active address here. That's the server reflexive address. For the reflexive address, you will never see a passive candidate, because in Lync, we don't try to send traffic to the reflexive addresses. For TCP, this is mainly done for security reasons, because when this was designed, it was believed it's not a good idea to just send TCP traffic to some reflexive addresses that you just learned. One other detail that you might see here is if you look at UDP candidates, the port number will be always different. So for UDP, we use a different port for RTP and RTCP, while if you look at TCP, it is, well, let's look here. It is the same port number that we use for RDP and RTCP. We do multiplexing there. Again, we didn't want to allocate as many TCP addresses because some people might see this as security risk if you just require to allocate a lot of TCP addresses. And by doing the multiplexing here, we just need only the half of TCP addresses to allocate. Okay, so this is what I send out to the other person in terms to tell the other person, well, I want to call you, this is where you can reach me. Now I want to see the 183 coming back, the other person telling me, well, I'm trying to establish a connection to you. And if I look at my log here, I can actually see that there are 2 183 session progresses coming in for this specific call. Any idea why I'm getting 2 and not only 1? There is a second ring on the other side. So in Lync, we are able to have not only one endpoint signed in, we can have multiple endpoints. Or we can set up simultaneous ring. If I call someone, I will try to establish a connection to all of the endpoints the person is signed in with, because I don't know which endpoint he will use to pick up. So in this example, Amit set up simultaneous ring to his cell phone. So while I'm trying to establish a connection to his Lync client, I'm always also trying to establish a connection to the mediation server and able to ring his cell phone. So if I look here at the first session progress, I scroll down a little bit, I zoom in, I can see here that the server it's coming back from is actually the mediation server. So this is the set of candidates, this is the SDP of the mediation server. If I continue scrolling down, I realize this time there's only one set of SDP. It doesn't include the fallback for 2007, because the mediation server already knows, well, if I'm be able to send out both, well, then I'll be able to understand both, so it only needs to send out the newer one. So the response will have always only one set of SDP. And I can see here all the candidates the mediation server is using. From an ICE perspective, the mediation server, it's just another ICE client. It's doing exactly the same as an internal client would do, so it looks exactly the same. Now I look at the second 183 session progress, and I can see here the candidates from Amit coming in. If I scroll up a little bit, I can see that Amit is using Microsoft Lync client. I can see the version he's using, and I can see all his candidates. He actually has quite a number of local candidates, 4 sets of them, because he has a lot of virtual network cards installed on his machine that he uses for his lab purposes. All of them will send out candidates. However, if we look now on the server reflexive address, only one of them, the primary one, will be used to discover our reflexive address to allocate our turn addresses. So this is the primary that contacts the edge server. Looking here at the IP address, I can find out which one it was. Perfect. In the slide deck, you will find, just for your reference, also these candidates collected one more time in a easier to read order form, because I sorted them, well, I layouted them. And if you look at the column 4, you can see the priority and the set before. The higher the priority, the better. So what we can see here very easily is that UDP has the highest priority with the type host. So obviously, we try to use UDP first. Next step, connectivity checks. Now, the 2 endpoints know where to reach each other. Now they will determine all the possible UDP and TCP port pairings. Of course, we will never communicate for UDP to TCP, but everything between UDP, we will test everything between TCP. There will be stun packets sent between these clients, and we will use them and find out if there is connectivity. Once we validated connectivity between two candidates, then we know we can use that, and we remember that for establishing then the final media session. So the next step is the candidate promotion. Now we found out all the possible media paths that we could use, and now we will pick the one with the highest priority. Usually, the one with the highest priority will be the more direct one. So if you can call someone peer-to-peer, then you will do that and not go over the relay. At the same time, UDP is preferred over TCP. So if we are able to do a UDP and a TCP connection, we will always do the UDP connection. There will be a final SIP invite, a re-invite, that includes only the final candidates. Looking at that, then we will learn what candidates we should use. Okay, and let's look at that. So we exchanged the candidates with the 183. Now Amit picks up, sends out the 200. That's still part of the media establishment. And here he still sends out his full candidate set, because we haven't negotiated the best candidates yet. So when we see the 200, because of picking up, it has the full SDP. Now I'm looking for the out invite, the re-invite. And if I look at that, I can see that now there is only a set of one candidate pair included, and that's the candidate pair that we will use for this specific call. So that's UDP, and it's actually the server reflexive address. So it means that he sends his traffic directly to my net device. Now I look at the next 200 OK. Well, on the 200 OK for that. Zoom in. I can see his final candidates, and they are UDP as well, server reflexive as well. So in this case, the two of us, we established a call that goes directly from me to my net, to his net, to him. So the AV Edge server is not part of the media flow in this case. However, we use the Edge server to discover all these candidates. So maybe one or two words more on troubleshooting. So I'm going back now to my candidate list, what I send out here. If you have media connectivity problems, most of the time it is sufficient to look at the candidate list to find out what could be going on. Always check, are there all the candidates that you expect to see? So you should see UDP and TCP reflexive candidates, and you should see UDP and TCP relay addresses. If you don't see any of them all, that means my client is not able to to communicate to the AV Edge server at all. Might be a firewall problem, might be DNS problem, whatever. Something is blocking my client from talking to my AV Edge server. If you see only UDP candidates, or if you see only TCP candidates, well, that means that it's just this port range, just UDP or just TCP, that's being blocked on your firewall. Or maybe the hardware load balancer drops packets, or maybe the hardware load balancer corrupts packets. So always look into this into this SDP if you see all the candidates that you expect. The connectivity checks itself, unfortunately, you cannot see in these logs. If you want to really see the connectivity checks, then you need to use tools like Netmon and run it on the clients to see where are they sending the packets and are they getting any responses. Now let's talk about different possible call flows. The topology we will use for this part has on the very left side home users. There's home user 1 and home user 2. They sit behind net or firewall. Then there on the right side is our company environment. So we have, again, the Access Edge server and the AV Edge server. There's an outer firewall and an inner firewall. And internally, I have work 1 and work 2. And, well, actually, these could be users, could be the AV MCU, could be mediation server, Exchange UM, everything that is doing ICE. It will, from an ICE perspective, everything is just an ICE endpoint. The very first scenario would be an inside user calling another inside user. So work 1 wants to call user work 2. The first thing that is happening, work 1 will discover all its candidates. Please note, even that both users are internal, we will still do the whole ICE process. Reason is, we want to establish the call as quick as possible. We don't want to guess where the other user is if we need to do something special or could take a shortcut. It's much easier if we just do the same process all the time. So we allocate all the candidates in order to call work 2. That includes the local candidate, and it includes the candidates on the AV Edge server. So now work 2 gets the invite, and will do the same. We'll discover the local candidate and the candidates on the Edge server. Now they will try to establish a connection. And all of this will happen virtually at the same time. They will try to connect directly to directly. Of course, this is the most optimal media path that we could establish. However, as part of the connectivity checks, they will also try to go over the Edge server. So work 1 user will contact its Edge server and will tell the Edge server, well, on my behalf, please contact to this candidate and establish a connection. So they could also be able to have this connection established, this media path over the Edge server. And that's actually a quite interesting scenario. Because if you look into the Microsoft documentation, one thing that is very clear is that Microsoft, sometimes I refer to it as the Microsoft Wonderland. In Microsoft Wonderland, internal firewalls don't exist. No customer has ever a reason to deploy an internal firewall. Why would they? It's something we don't believe in, so we don't support it. If you have an internal firewall, well, obviously you're not going to do any peer-to-peer calls. But now we learned about this ICE functionality. And actually it tells me, well, the clients will try to connect peer-to-peer. But if for some reason peer-to-peer is not working, well, they know already their Edge candidates. They will talk over the Edge server. So, whoops. That was brilliant. Well, if the Edge server is not available, something is broken in your environment.
Yeah, but internally they will call each other.
Yeah, well, if you have an Edge, so regarding Microsoft documented supported deployment, you don't have an internal firewall, calls will always work peer-to-peer. And now, if you have a firewall, what you just learned tells you, well, if we have an internal firewall, they can still go over the Edge server. Of course, if there is no Edge server, well, they still cannot call each other.
No. They in the same net, no firewall between them both.
Oh, so you're saying there is no Edge server at all and it's supposed to be? Yeah, well, they will still do the ICE process, but it will be very shortened because there is no Edge server. The discovery of candidates will be just, oh, I have local candidates, no Edge server, no one to connect, perfect. I send my local candidates, I get local candidates from the other one, we exchange them, call, and it will work. It looks exactly the same, just with much fewer candidates. Okay, so again, to this scenario. So learning now that we have an internal firewall, we can still do calls over the AV Edge server. Yes, this will work, but this is not how the product was designed, and it's not what we document. So this is really a very, very dark gray area of what you can do. The problem here really is, if you would do that, if you have internal firewalls and you just say, oh, well, we put in this AV Edge server, it will fix everything, yeah, connectivity will be possible, but there are a number of problems that you introduce. One, well, the media path might be physically just much more longer than it was before. Because maybe work user 1 is sitting on one level in the building, work user 2 is sitting in another level, and they have firewalls between each of the levels. So now instead of having a peer-to-peer call, which would be really quick, they need to go to the AV Edge server, which might be in a data center in a different country. So you really don't want to send all your traffic first to Ireland before it comes here again. Additionally, well, so it will not help your media quality because of the additional delay, there might be additional packet loss, and so on and so on. You will put much more load on your network because now it's not just peer-to-peer, but it needs to go to your data center as well. Also, we don't have any scaling numbers for the Edge server in this situation. The numbers we give you, how to plan, how to scale for Edge server, well, they assume that you have a certain percentage of users externally, and only these users will use the AV Edge server if they need to try someone internally. But now, every single call needs to go to the AV Edge server. So as you can see, there are a number of problems that you introduced. So it's something that, well, while it will work, it's not recommended. And you should definitely check with support. If you are in a specific situation that gives you no other option than to do that, I would recommend open a support ticket with support, describe them the situation, and get sure that whatever you are going to do, they will support you when you run into a problem when it didn't work. Oh my God, I killed PowerPoint. No, it's back. Okay, next situation. One user is internal in your internal network. The next user is outside at home. Same process will start. So the work user will discover all its candidates, will contact the home user will discover all its candidates. And now they will try to establish the most optimal media path. Of course, direct to direct will not work in that case. So one possible media path would be that H1 connects here directly to the high port, the candidate that user 1 discovered, well, user 1 sent out for TCP, or we will do the same for UDP. If this doesn't work for some reason, because maybe your firewall administrator decided to block all the ports on the 50K port range, well, then the home user 1 needs to go to his own edge server on 3478 or 443, and they will do a hairpin, and within the edge server, they will do this. That sounds pretty easy if you have a single edge server, but it also means if you have multiple edge servers, now 2 edge servers are involved in this call, and we are going to address this specific scenario in a later slide. Next scenario, you have 2 outside users. User 1 at home discovers its candidates, sends it to user 2. Most optimal media path would be direct to direct, because maybe they are really in the same network. Think of a hotel. Both users are connected to the hotel network. They might be able to do a peer-to-peer call. They also might be able to do this reflexive to reflexive call from net to net, like I did in the log with Amit. If not, well, there's still the option to go over the AV Edge server, either directly or using the AV Edge server as the relay. If we talk now about 2 different companies having a federation and trying to do media, it gets a little bit more complicated. We have here at the very left side a user, work1, being internal to a company. They have Edge server deployed. They have Lync with Edge servers deployed. Then they have the firewalls. And then there's a different company. They have also, well, OCS deployed in that case, and an internal user. I'll start here out with OCS 2007, because we changed a little bit how the product worked. And if you have federation still with OCS 2007, then this is something that will be important.
Not R2.
R2 behaves the way Lync behaves. So there's OCS 2007, old, and then there's Lync and R2. No change between R2 and Lync in that behalf. Okay, so for that specific scenario, 2007 Edge servers. So work user 1 will discover the candidates, will send it to work user 2, discover the candidates, and then they will, on this famous 50,000 port range, have a connection from Edge server to Edge server on the 50K port range. That means in this scenario, if you decide to close the 50K port range or to not open it, calls will not be possible between 2 federated entities if they are internal to their networks. Now, in R2, we introduced the tunnel mode. So in this case, we have on both sides either R2 or Lync Edge servers. Same happens. But now, when we try to establish a call, the Edge server will send a special packet to the other Edge server from port 3478 to port 3478 in order to find out, is this also an R2 or Lync Edge server? Because if it is, we can use the tunnel mode, and then we can send all the traffic for UDP just from 3478 to 3478, and we don't require these high ports anymore. If you look at the candidate list, the candidates will still include all the high ports. So the candidate will still say it's port 54,203. However, the Lync edge server will just try to contact the other edge server on 3478 for UDP and will tell the edge server, well, I'm supposed actually to connect to port 54,302. However, I'm an edge server, so, well, you allowed that, so let's just use these ports for it. And the other edge server will say, well, yeah, I remember I just allocated these ports for this user, so let's have the call. For TCP, we are trying to do something very similar. However, because how TCP, the protocol, works, if you have one source port and one source IP address, and you establish a connection to another destination IP address and destination port, you can have at the same time only one connection. Now think of two really big companies having this federation, and they want to do a lot of desktop sharing. Well, it wouldn't be really helpful if they could have only one media session at a time. So the trick we are doing here is we are using a port in the 50K port range as a source port. So we establish a connection from 50,000 whatever to 443 in order to be able to do desktop sharing and file transfer and the fallback for audio video if we need to. From a firewall perspective, that means I need to open the firewall to allow my server to connect to 443. If my firewall is configured that way, everything will work fine. I will be able to do TCP media sessions. If my firewall requires me to also configure the source port, then I need to configure 50K source port because that will be the source for the connection being established. Okay, so how does it look like if now one of my new servers wants to talk to an OCS 2007 edge server? From the client perspective, the process is the same. And now the R2 or Lync edge server will again send this UDP packet, but the 2007 edge server doesn't know what to do with it. So we wouldn't be able to establish the connection. The same for TCP. We try to establish, but it doesn't work. So if we need to talk to a 2007 R1 edge server, we need to open the 50K port range because that's the only ports that the legacy edge server will be able to listen on. Okay, so summary. What are my requirements for the 50K port range? And now, please note that's the minimum requirements, and the following slide will explain why this is the minimum and not necessarily the optimum. If I have an OCS 2007 AV edge server, I need 3478 and UDP inbound and TCP 443 inbound. And this will be the ports that my remote users will use if they ever need to contact my AV edge servers to allocate candidates. Also, I need the UDP and TCP port range 50,000 to 59,999 inbound and outbound for the media establishment. Now, if we talk about R2 and Lync, we need as well the 3478 UDP and 443 TCP inbound, but we need also the 3478 to 3478 UDP outbound. This is how Edge communicates to other AV Edge servers. And we need TCP 50K to 59999 to port 443 TCP. That's the way we communicate TCP to other AV Edge servers. If we want to have interoperability with OCS 2007, we need to open the 50K port range inbound and outbound for UDP and TCP as well. So that's the minimum. Now let's talk about the optimal configuration. I want you to concentrate now on the left side where the port range is open. So you have two Lync clients, and there are two AV Edge servers. And these could be Lync clients in different companies. So one is Contoso, one is Litverink. But actually, it could be also the very same company, and they are just assigned to different AV Edge pools. So you have your users in US, you have your users in Europe, and one is using the US and the Europe. Well, even more, it could be users assigned to the same AV pool if you have a pool of servers. So for each call I'm establishing, I will connect to exactly one AV Edge server within my pool. It could be the case that the person I'm calling is assigned to the same AV pool, but just for this one call, he or she connects to a different AV Edge server. And this is what's going to happen. Let's assume for some reason a direct connection is not possible, because maybe they have a NET device, symmetric NET, that wouldn't allow a net-to-net connection, or maybe there's just a firewall blocking them. So what usually would happen now is that the one client would connect to its AV Edge server on port 443.3478 in order to allocate the candidates, but it will also stay connected so the Edge server can make connections on behalf of the user. It will send out the candidates, including the 50K port range, and now the other client can just connect to this AV port, to this 50K port range, and you have here a nice media flow, including one AV Edge server. Of course, it could be just the other AV Edge server, same situation, but there's only one AV Edge server involved. Now, let's go to the right side. Think about what happens if the port range is closed. Again, for some reason, direct peer-to-peer does not work. So they connect and send out the candidates, and now the other client tries to connect to the 50K port range. However, there's a firewall blocking the client. So it's not possible to do that. So what the client needs to do now is, over the connection to its own Edge server, it needs to tell the Edge server, well, please, on my behalf, connect to this other Edge server. The Edge server, edge to edge, allows 3478 to 3478 to happen. A client will not be able to do that. Me as a client, I will never be able to connect to a different AV Edge server. For that, I didn't get candidates, that I didn't use to allocate candidates for this specific call. So I need to ask my Edge server, please make the connection on my behalf. So now we have, the user will be still happy because we still have media connection going on. However, the media path might be a little bit less optimal because now we have two AV Edge servers. And this might be becoming more important if you think about really international companies or federations. So you have your Edge servers in the US, you have your Edge servers in Europe, and now, because you have two Edge servers in the way, now it needs to travel multiple times around the globe. Bottom line is, yes, you can close the 50K port range to some extent, as said before. You don't need to open any inbound 50K port ranges at all if you have only federations with Lync or OCS 2007 R2, but there is some benefit if you still open it. Okay, one other important consideration when you deploy Lync Edge servers in a pool is that each AV Edge server needs to have the same certificate. And when I say the same certificate, it means it needs really to be the very same certificate. So you need to take the certificate from one AV Edge server, export it, including the private key, and import it on all the other AV Edge servers in the same pool. The reason is, as said before, we use this certificate to create the credentials for a user. So let's just see an example. So the user signs in, gets the credentials from one of the Edge servers. And now there is some issue. The Edge server is down. So the next time the user wants to do the call, it will still send the request to one of the Edge servers in the pool, and now it's load balanced. No matter if you use hardware load balancing or DNS load balancing, the user is load balanced to a different AV Edge server. Because the certificate is the very same that what was used to create the credentials, the certificate will be used again to validate the credentials. So the Edge server doesn't actually have some table where it would store all the user names and credentials that it created. It just uses the certificate to validate, well, yes, I or someone else with this certificate created these credentials so I can validate them. So if you would not use the same certificate, then you would run into very strange issues where sometimes calls would work, sometimes they wouldn't. Important to remember, always use the very same certificate. Yes, please.
The load balancer also needs a certificate, but it doesn't do the authentication through the certificate.
The question is if a load balancer needs any certificate. If we talk about Edge server, no, it doesn't. It has no certificate. It does no authentication whatsoever. It's just getting inbound traffic and distributes it to the servers, and the servers will do authentication if necessary.
Okay, but someone do require you to use a certificate.
There is a certificate requirement if you talk about mobility clients for the front-end server, but this is a very different topic. If you want, we can follow up after the session. Okay, so how does all of that, what we just discussed, help me to troubleshoot media connectivity issues? So the first thing is look for the MRAS credentials. Well, if there's any media problem, ask for a client log. Get the client log from a fresh sign-in, look for the MRAS. Is there the MRAS? Does the user get credentials? Well, then you know at least the front-end server can talk to my edge server. The next thing, well, and if it does not work, try from your front-end server to connect to the edge server. The easiest thing I would recommend to is go to the front-end server, try telnet to the FQDN of the internal edge interface. Because if you do the telnet to the FQDN, it will tell you in one step if, well, there is it can resolve the IP address and if it can connect to that specific port or is blocked. If you don't see no stun or turn candidates, then it's the connection between the client and the server. Again, for TCP, telnet is a pretty useful tool, so just telnet to the FQDN of the edge server on port 443, see if you get a connection. For UDP, you can use tools like port query. If you have just UDP or TCP candidates missing, well, probably the firewall or the load balancer, someone is dropping packets, so look into that. It could also be, in Lync, you are allowed to net the external IP addresses of your AV edge server, if you have only a single AV edge server or if you're using DNS load balancing. Also check that whenever your edge server sends out candidates, that it uses the correct IP address. If you configured in Topology Builder the wrong external IP address, the edge server will actually believe it has a different IP address and will use this wrong IP address and send it out as candidate. Obviously, others won't be able to connect to this IP address. Where can you find these logs? So if we talk about Lync or Office Communicator, go to the options, say activate, turn on logging in Lync, well, or in Communicator, and the logs will be found in the user profile in the tracing folder. If you still use Live Meeting, I really hope you don't, but if you still use Live Meeting, there is a registry key that you need to set to enable the file tracing, and it will not show you all the tracing that Live Meeting does do, but it will show you the tracing that is important for you if you want to troubleshoot ICE issues, and then there will be also a log in the user profile tracing. You can also open it with Snooper, and you can also investigate if you can find the candidates you expect to find. Here, a quick cheat sheet, what you can look for in the logs. The first two are the AV Edge provisioning. Actually, if you just search for MRAS URI, you get just, I think, the first result that we looked at earlier. If you use for the credentials request ID, then you should see the response from the server. I usually decide just to search for MRAS and find all three interesting log entries. For the ICE negotiation, address discovery, search for A equals candidate to find just the addresses that have been discovered and the addresses that have been exchanged. And if you want to see the candidate promotion, the final candidates that are chosen, search for A equal remote candidate. I'm, as a lazy person, I just search for candidate and I can find all of them. One note for the candidate promotion. After someone picked up a call, it can take several seconds until we decided on the final candidates. So it's possible someone picks up a call that you talk over the edge server, but eventually a better media path becomes available, so within the first few seconds, and that we switch to, well, over the net, for example. However, the final re-invite will only be sent out after we decided which are the final candidates. So if you want to see the candidate promotion in your log, get sure that your call was on for at least, I would say, 10 seconds. Get sure, maybe, say, 15 seconds. If you just pick up and discontinue the call instantly, you will not see this last result in your logs. Okay, so as a review, what did we do? We talked about what is this AV Edge server doing, why do we need it, how do we find the most optimal media path, and how can I do read client logs. And all of that really should help you to troubleshoot. So I hope it was interesting to you as well. You should now be able to understand the call flows, and this will really help you troubleshoot a lot. Related content. Today at 2:45 in this very room, there is a session by Rui, he is in the back of the room, talking about security on Edge server. There are some hands-on labs that you can do. I will personally be tomorrow from 1 to 3 at the Lync demo booth in the exhibition hall. So if you have any questions, I will also stay after the session. But if you have any questions, feel free and come and talk to me. There's also my email address in the slides. There are some great exams you can take. There are even better resources. Please do your evaluations. These are very important for us, especially if you think a session like this, deep dive session, level 400 is useful to you. Evaluations is a really good way to let the organizers know that this is useful and that we can do more of these sessions in the future. Well, and with that, thank you very much.